All right, so get this. The Nobel Prize in physics just went to 2 AI pioneers.
Really?
Yeah, 2 this year.
Wow. That's pretty huge, isn't it?
I know, it kind of blew my mind
Yeah.
when I heard that, and it really got me thinking about how we got here.
Right.
How did physicists end up kind of revolutionizing AI?
Well, physics is all about like the fundamental principles of how things work,
Mm-hmm.
and that includes really complex systems like the human brain.
Yeah, so let's start with one of those Nobel laureates, John Hopfield.
Okay.
His work back in the 1980s was all about like bridging physics and biology
Right.
with something called Hopfield networks.
So these networks, they were really inspired by how the human brain stores and processes information.
Okay.
And Hopfield, being a physicist, he had this idea to model neurons, those brain building blocks, as
Yeah.
like simple on-off switches.
So you're just saying our brains are basically massive biological computers.
Yeah, essentially. And what's remarkable is that he actually showed how these simple on-off states of neurons could form complex patterns. And that offers a physical explanation for how memories are formed.
Wow, so like cracking a code hidden in our brains.
Yeah, you could say that. And it wasn't just like a breakthrough for neuroscience.
Right?
These Hopfield networks, they laid the groundwork for a whole new type of artificial neural network. The kind that powers so much of the AI we see now.
Oh, wow.
So yeah, it's pretty amazing.
So it's like he took inspiration from the brain's hardware
Yeah.
to create a blueprint for AI software.
That's a great way to put it. And, the effects of his work are still being felt today.
Really?
Yeah, his models help neuroscientists understand all sorts of things, like memory and navigation in the brain and in AI. His research provided this fundamental understanding of how artificial neurons learn and process information.
So if we can understand the physical mechanisms of the brain,
Yeah.
so does that mean we're on the path to creating AI that's even more human-like?
It's a real possibility for sure.
That's amazing.
Yeah. Hopfield's work just opened up a whole new world of possibilities, for understanding intelligence itself.
Okay, so we've seen how physics gave us a framework for understanding the brain,
Right.
which then inspired this development of artificial neural networks.
Mm-hmm.
This is where things get even more interesting.
Definitely.
Because the story of AI and the Nobel Prize
Right.
doesn't end there.
Oh, you're right about that. The second Nobel laureate, Geoffrey Hinton, took these ideas even further, and that's a whole other deep dive waiting to happen. So we talked about how John Hopfield's work was like inspired by the structure of the brain.
Right.
Well, Geoffrey Hinton, he took those ideas and just ran with them.
Yeah, he's often called the godfather of AI.
He is.
So what exactly did he do that was so groundbreaking?
His key contribution was something called the backpropagation algorithm.
Backpropagation.
Yeah.
Okay, that sounds kind of complicated.
It's a method that's essential for training deep neural networks, the kind that's behind all the AI stuff we're seeing.
Okay, break it down for us.
Imagine like learning to ride a bike.
Okay.
You wobble, you fall, you get feedback, you adjust each time. Backpropagation, it works in a similar way.
Cool.
It lets a neural network learn from its errors and fine-tune its connections to get better.
So the AI is practicing
Yeah.
and getting better?
Yeah, just like we do when we learn a new skill.
So how did this backpropagation algorithm like revolutionize AI?
Well, before backpropagation training, a neural network was really difficult and slow.
Okay.
But with this algorithm, AI systems could suddenly learn much more efficiently and effectively.
He was like a game changer.
Exactly.
So Hinton really unlocked a whole new level of AI potential.
Yeah, and this is where it gets exciting because Hinton's discoveries, they've had a huge impact on our daily lives.
Oh, so?
They've revolutionized things like speech and image recognition. They're making AI systems more human-like in how they see and understand the world.
It's crazy to think that something as complex as, understanding language or identifying objects in a picture can be broken down into math.
It is remarkable, and it's this ability to kind of mimic human perception and cognition that's fueled so many of these technologies we use every day.
Like, give us some examples.
Well, think about the AI in self-driving cars. It needs to be able to recognize pedestrians, other cars, traffic lights, all in real time.
Right.
Or think about virtual assistants, like Siri or Alexa.
Yeah.
They rely on speech recognition to understand what we're asking them.
Yeah, and what about personalized recommendations?
Exactly, or targeted advertising.
Right.
All of these technologies are powered by algorithms and deep neural networks that were made possible in large part thanks to Hinton's work on backpropagation.
So we've got these 2 physicists, John Hopfield, getting inspiration from the structure of the brain, and Geoffrey Hinton figuring out how to make artificial neural networks learn.
Right.
And together, their work kind of laid the foundation for this AI revolution.
Yeah.
It's amazing how these seemingly completely different fields of physics and AI are actually so intertwined.
It is. It's the beauty of science, you
Yeah.
know? The connections, the unexpected intersections, and how these abstract ideas can lead to huge breakthroughs.
So it's not just about the power of science.
Right.
It also shows how important AI is as a field of study.
Yeah.
I mean, for two physicists to win the Nobel Prize in physics for AI, that's huge.
It is a really big deal, and it brings us to the heart of what we're talking about today.
Yeah.
What does this Nobel Prize mean for the future of AI?
So two physicists win the Nobel Prize in physics for their work in AI.
Hmm.
I mean, that's got to be a turning point for the field, right?
Yeah, it's huge. It's like the scientific community is saying, hey, AI is not just some little offshoot of computer science anymore.
Yeah.
This is a major scientific discipline.
So AI has officially arrived.
Yeah, it's like it's earned its place at the table with physics, chemistry, and biology.
What kind of impact do you think this will have?
Well, I think we're going to see a lot more investment in AI research.
Mhm.
You know, this Nobel Prize is going to inspire a whole new generation of scientists and engineers to get into AI.
So like a surge in innovation.
Yeah. Definitely, maybe even an acceleration of all the progress we've already seen.
It's pretty exciting to think about all the possibilities, but I also remember hearing that Geoffrey Hinton, one of the winners,
Right.
he's expressed some concerns about the risks of AI, like AI becoming more intelligent than humans.
He's talked a lot about responsible AI development, and those concerns are valid as AI gets more powerful. We need to think about the ethical implications and, what could go wrong.
So it's not just about what's possible technologically.
Yeah.
It's about using this tech for good and being prepared for the challenges.
Exactly. And that's a conversation that needs to involve everyone, not just scientists.
Right. Policymakers, ethicists, everyone.
Yeah, exactly.
So we've gone from exploring the brain as a computer to figuring out deep learning,
Right.
and now AI is winning Nobel Prizes.
Yeah.
It's been quite a journey.
It really has. And it all started with this two physicists who thought differently. They saw connections that others didn't and pushed the boundaries of what we thought was possible.
It's amazing how their work has not only helped us understand intelligence better,
Yeah.
but also paved the way for a future with so much potential.
Absolutely.
And that's the thing about science, right? It's
Yeah.
always evolving. Who knows what other fields will contribute to AI in the future, or what other amazing discoveries are out there.
The possibilities are endless.
That's right.
Yeah.
So keep exploring, keep asking questions, and never lose that sense of wonder.
Couldn't have said it better myself.